Objective A. Determine if an equation is quadratic or linear. Number 1. X plus 9 times x minus 9 equals 3. I would say this is definitely a quadratic equation because if you expand the equation, the highest degree of the term will be the second degree. You could also look by looking at these two, right? X times x, it's going to give you x squared. And all the other products, it's going to be lower than the second degree. So yes, this is a quadratic. Since we're here, let's just look at number 2 at the same time. Number 2 says 4x plus 3 divided by 7 equals 5. If you check out the highest degree of your variable, it's going to be 1. So apparently, this is a linear equation. Yeah, actually it's not a yes or no question. It's just asking you whether or not it's quadratic or linear. So number 1 is quadratic and number 2 is linear. Moving on to objective B. Solve a quadratic equation by factoring. The general form for a quadratic equation looks like ax squared plus bx plus c equals 0, where a, b, c are coefficients and a is not equal to 0. If we're going to solve this quadratic equation, for some time you can factor the left hand side, the ax squared plus bx plus c, using what we discussed in earlier sections. And that's going to give you something times something equals 0. It's usually going to be a coefficient. Let's make it d times x plus e, and then you have f times x plus g. So that's usually what's going to look like after you factor the left hand side. And then to solve this, we simply make each of the factors equal 0, because there is something called the zero product property. Zero product property says that if you have something times something, let's say x times y equals 0, then x could be 0 or y could be 0. And that's basically how we solve quadratic equation by factoring. Let's look at an example. Number 3, x minus 5 times x minus 7 equals 0. This is basically talking about two factors multiplying and then you get 0. According to our zero product property, each one of them could be 0. So x minus 5 could be 0 or x minus 7 could be 0. And now we have two linear equations we can solve very easily. It's just a one-step equation. Plus 5 plus 5 plus 7 plus 7. And we obtain x is 5 or x is 7. Number 5, x squared plus 7x equals 8. This one is definitely a quadratic equation. Before you factor it, make sure you move every term to one side of the equation and then you have a 0 on the other side. Usually we move everything to the side where the coefficient of x squared is positive. In this case, x squared has a positive coefficient on the left hand side, so I'm going to move the 8 to the left hand side. Perform inverse operations, which is subtracting 8. You get x squared plus 7x minus 8 equals 0. Now we're ready to factor the left hand side. So what we're looking for is, we're looking for two numbers such that when we multiply, you get negative a. When you do cross multiplication, you will get 7x in the middle. And the choice in this case will be positive a and negative 1. So that factors the left hand side. According to zero product property, each of them could be 0. Solve for x, we obtain x could be negative 8 or positive 1. Number 7, x squared plus 11x equals 0. This one is very interesting because we only have two terms on the left and then you already have a 0 on the right. Well, it's still a quadratic equation, so we will follow the same way, factor the left-hand side, the quadratic part. This time, you don't need to perform any educated guess. All you need to do is factor out a GCF. The GCF between these two terms is x. Once you factor out the x, we will have x plus 11 left inside the grouping symbol equals 0. And now apply the zero product property. Each of these factors could be 0. That means x could be 0 or x plus 11 could be 0. Solve for each of them, we obtain two solutions, x is 0 or negative 11. Number 9. 9 minus 42x plus 49x squared equals 0. Before we do anything, I would like to make sure it looks like the general form of the quadratic equation, which has a descending order of quadratic polynomial on the left-hand side and a 0 on the other side. That requires us to rewrite the left-hand side. 49x squared highest degree, and then negative 42x, and then positive 9 equals 0. And now we are ready to continue. Always think about GCF. Think about whether or not we could factor out any GCF, especially for quadratic expressions like this where you have large numbers. By looking at the coefficients 49, 42, and 9, unfortunately we have nothing to factor out. That means we're going to go straight to educated guess. Under 49x squared, I'm going to try 7x and 7x. Under positive 9, I'm going to try negative 3 and negative 3. And then doing a cross multiplication to see what do we have. It's going to give me negative 21x. Minus 21x. And that's negative 42x. And this is exactly what we wanted in the middle. So our guess is correct. Then we're going to write our answer horizontally for the factor form. Not the answer, sorry. Not the factor form, horizontally. We have 7x minus 3 times 7x minus 3 equals 0. It's the same factor. Basically means it's a perfect square trinomial. So some of you might already use the formula that we discussed from previous section to factor it. You're welcome to do that. And then since they're the same factor, I'm just going to write it once. So 7x minus 3 could be 0, which indicates that x is 3 over 7. Number 11. X squared plus 11x equals negative 18. First thing to do, move everything to one side, 0 on the other side. Since x squared has a positive coefficient on the left-hand side, I'm going to add 18 to both sides. Now we have x squared plus 11x plus 18 equals 0. And then perform educated guess. It's going to give you x plus 9, x plus 2 equals 0. Solve for each of them by using the zero product property. You have x plus 9 equals 0 or x plus 2 equals 0. And that gives you two solutions, negative 9, negative 2. Number 13. 32x squared equals 2. So the first thing to do, just like before, gonna move the 2 to the left hand side. And we obtain 32x squared minus 2 equals 0. And then GCF. We could factor out 2, and we have 16x squared minus 1 equals 0. And notice that inside that grouping symbol, we have a difference of two perfect squares. Using the formula, we could factor into 4x plus 1 times 4x minus 1. Then, applying zero product property, we have 3 factors on the left hand side. 2, that's one of the factor, but this one is not 0. We also have 4x plus 1, we also have 4x minus 1. According to zero product property, the product will be 0 if 4x plus 1 is 0 or 4x minus 1 is 0. Solve for each of them, we obtain 2 solutions, negative 1 over 4 or positive 1 over 4. Number 15. 2x plus 3 times x minus 5 equals negative 11. The first thing to do is get rid of the grouping symbol so that we could transform it to the standard quadratic equation form ax squared plus bx plus c. If you apply FOIL, we will get 2x squared minus 10x plus 3x and minus 15 on the left hand side, and it's equal to negative 11. And then we're going to move that negative 11 to the left hand side because coefficient of x squared is positive on the left hand side. Plus 11 plus 11. At the same time, I'm also going to combine like terms on the left hand side. So we do have 2 like terms right here. We will have 2x squared, negative 10x plus 3x, that's negative 7x. And then you have negative 15 plus 11, that's negative 4, equals, on the right hand side, we have a 0. And now we're going to do educated guess on the left hand side. Under 2x squared, you only have one choice, 2x and x. Under negative 4, let's try positive 1 and negative 4. Perform cross multiplication. Let's check. 2x times negative 4, that's negative ax. X times 1, that's positive x. Adding them, you get negative 7x. And this is exactly what we want in the middle. So our guess is correct. Therefore, we write our answer horizontally. We have 2x plus 1 times x minus 4 equals 0. So do not forget that we're solving an equation, we still have equal 0 on the other side. And then by zero product property, each of these 2 factors could be 0. 2x plus 1 is 0 or x minus 4 is 0. Solve for each of them, we obtain 2 solutions. X could be negative 1/2 or positive 4. Number 17. 4 times x squared plus 1 equals 17x. Same thing as before, we're going to get rid of the grouping symbols and move everything to one side of the equation. Distribute 4 into the grouping symbol, we obtain 4x squared plus 4 equals 17x. Moving 17x to the left hand side, we obtain 4x squared minus 17x plus 4 equals 0. Check whether or not we could factor out in a GCF. It's always a good habit to do that whenever the coefficient of x squared is not 1. Unfortunately, we cannot factor out anything other than 1, then we go straight to educated guess. Under 4x squared, I'm going to write 4x and x. Under positive 4, I'm going to write negative 1 and negative 4. Perform cross multiplication. To verify, we have negative 16x minus x, that is negative 17x, which is indeed what we are looking for. So our guess is correct. We write our factor form horizontally on the left hand side. 4x minus 1, x minus 4 equals 0. Each of them could be 0. 4x minus 1 could be 0, or x minus 4 could be 0. Solve for each of these two simple equations. We obtain two solutions, 1 over 4 or 4. Number 19. X plus 2 times x plus 12 equals 4x. Distribute and then move everything to the left-hand side. Combining like terms on the left-hand side, 12x plus 2x, that's 14x, plus 24 equals 4x. And then I'm going to move that 4x to the left-hand side. So we have this quadratic equation, x squared plus 10x plus 24 equals 0. It's a very simple quadratic expression that can be factored rather easily. And then we apply zero product property. Each of these two factors could be 0. Solve for x, we obtain two solutions, -4 or -6. And by the way, it's always a habit to check whether or not your solutions are correct. If you're doing this for your exam and you have extra time, always make sure that you plug back into the original equations to check whether or not your solutions are correct. Objective C. Solve applied problems using quadratic equations. A city planning committee wants to increase the size of a square parking lot if the length of the lot is to be increased by 16 feet and the width of the lot is to be increased by 40 feet. The resulting parking lot would have an area of 9,900 square feet. If the lot is to be enclosed by a chain link fence, how much fencing will be needed to enclose the parking lot? To help you visualize this problem, it's probably a good idea to do a diagram. Oh, this doesn't look like a square. Let's try again. Alright, much better. So this is the original parking lot. We don't know the dimension. And then it says that they increased the length by 60 feet. So this is let's make this one length, this one width, even though it doesn't matter which side you make them. The length is increased by 60 feet. So let's actually do 60 feet. I don't know how much it is, so we'll just make it like 60 feet right here. And then the width is increased by 40 feet. So let's make it slightly shorter than what we did. And this is 40 feet. The resulting parking lot will have an area of 9,900 square feet. To demonstrate that, I'm gonna connect this part and this part. And if I shade everything inside, including the original, that's gonna be 9,900. So this is the new parking lot. The original is the blue one, and then the new parking lot is the blue plus the green. Now let's look at the question. The question is asking you basically the perimeter of the new parking lot. So actually it has multiple parts that you have to solve. This question is not like a one-step problem. Apparently we're missing something, I would say. We're missing the original parking lot dimension. The original is a square. So what I can do is instead of using L and W, I could just use one variable to represent the parking lot original dimension. Let's make it, let's make it S. This one is also S. This is also S. This is also S. And then we are going to create equation. The equation has something to do with the 9900 square feet, which is the total area of this new rectangle that I created. By looking at the diagram, the new length will be S plus 60, and the new width will be S plus 40. It's a rectangle. To calculate the area of a rectangle, you simply multiply the length and the width, and it's gonna give you 9900. So this is the equation that we constructed for the area. Now let's simplify this equation and put it in the general form ax squared plus bx plus c equals 0. Distribute on the left hand side, you will get s squared plus 100s plus 2400 equals 9900. Move 9900 to the left hand side, so you subtract both sides by 9900. We obtain s squared plus 100s minus 7500 equals 0. Now this is in the general form of a quadratic equation. We could factor the left hand side and solve by zero product property. On the left hand side, write the factor form, put the s, and then think of two numbers such that when you multiply, you get negative 7500. When you add them, you get 100s by doing the cross multiplication. So I didn't write the table, but if you do the table, you will get the same idea. The two numbers that will work is positive 150 and negative 50. Solve for each of them, you will get two solutions. S could be negative 150 or positive 50. However, think about the context. S represents the side length of a parking lot originally, and it has to be non-negative. Therefore, negative 150, you could cancel that. You could cross that out. We're not going to take that as a solution. S has to be 50 feet. And now we're ready to calculate the perimeter of this new parking lot. So you could plug it in back into the original diagram. This is 50. This is 50. By looking at the diagram, the new length is 50 plus 60. That's 100 feet. The new width is 50 plus 40. That's 90 feet. The perimeter, it's simply 2L plus 2W. That's the total distance around the parking lot. And that will give us 2 times 110 plus 2 times 90. Calculate this, you will get 400 feet. That will be the perimeter of the new parking lot. And that's also how much fencing will be needed to enclose the parking lot. Thanks for watching.